Hey everybody, this is Larry. This is day 15 probably, if it loads, of the Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord, let me know what you think about this one. Yeah. Uh, well, okay. There you go, finally took. Yeah, I'm a little bit tired today. Yesterday I did, my setup exercise, and today it's a little bit sore. Not in all the places, probably could work a little bit more, but, trying to ease myself back into it. I think that's one thing with age is that when you get a little bit older, your recovery is also a little bit slower. It is what it is, and you just have to take account for it. But yeah, let's take a look at today's problem. We have 1574, shortest subarray to be removed to make array sorted. Given it an integer array R, remove a subarray from such that the remaining elements are non-decreasing. Return the length of the shortest subarray to remove. Subarray is a contiguous subsequence of array. Okay. This is such an... I mean, it's true, but it's still like very awkward phrasing. Like if you don't know what subsequence is, this isn't going to help you, right? But so like you're defining something with another definition almost for it's technically precise, but also like just enough to be like, come on, you could be a little bit more better about this. But okay. So we want it to be non-decreasing, so going up, right? Okay. What is the n here? N is 10 to the 5th. Yeah, I mean, I don't know that I think the first thing I want to say is that I just don't see why this one is tricky, but just want to make sure that I'm reading it correctly. And it is like just enough, like, there's just enough like deviation that you're like, oh, what are they asking for? But it's also like just very standard, right? Because then now it is just longest increasing subsequence, right? Oh wait. Okay, actually, wait, no. I think I did confuse. I say all that about subarray and subsequence, and I confused myself. So let me recorrect myself, because then that is just wrong, right? Because it would have been longest increasing subsequence if you're able to remove any subsequence, because then it's just like the dual, and that's why I got confused on. But okay, so it is a subarray. So give me a second. My apologies. Let me reset my mental thing for a sec, right? So the thing is that there's always an answer, because you can always remove every element, or maybe you can remove all elements except for one or something like this. So there's always an answer. So, or that's your max case, really. So then now, the second way that I would try to think about is trying to think whether I can brute force every, like, not like brute force, because of course real brute force may be like n squared or n cubed, depending on how you, different problems and different variations. But even n squared is too slow, so of course I'm not even going to try to think about n cubed. And here, the way that I would maybe actually think about it is that given an array, right, is that what does removing a subarray really means, right? Removing a subarray means that, okay, let's say there were only 3 cases, which is that you remove some chunks in the middle, you remove some chunks in the beginning, or you remove some chunks at the end, right? I mean, I know if you want to be, depending on how pedantic you want to get with the cases, right? In that you can also say that you can also say that, these are sub cases of the whatever, but yeah, okay, fine, whatever, right? But these are just kind of be more explicit. And in all these cases, it just means that going from left to right after you remove these, just to put another way, after you remove these, going from left to right, it is going to be increasing, right? Or non-decreasing. So it could be monotonically increasing. So that's really the idea. And then now, the idea is that, okay, well, given it this number, how, to the left, how did that happen? To the left, how do we join the left to the right, right? And that's really the idea. And maybe in that case, there's some there's some cases with the left, the one where you start the left and the right, and you can actually get rid of these cases by just adding like sentinel values. For example, if I have negative infinity first and then infinity at the end, which does not change the answer because, whatever, yeah, it should not change. Well, it doesn't change the answer because well, it doesn't change the answer, right? Because negative infinity will always be smaller than the smallest number, so it will never change that, and infinity will be the greatest number, right? And as a result, though, you move the instead of deleting the left side, now you only have one case because it is now deleting. It goes from negative infinity to whatever you want it to be, and then whatever the left side is, and then going to infinity. So that's really the thing here, right? Yeah. Yeah. So okay. So that's the first thing I would try to do. Okay, and then now, yeah. Now, how would I? What would I try to do to kind of fix this, right? I think there really only a couple of ways, and in that way, I would try to figure out how the ways to brute force intelligently, right? And what I mean by that is that there will only, at this point, without a loss of generality, there are really only two ways of doing it, and both of them are kind of similar, which is similar to what we talked about in either yesterday or days before this video with J and I, right? Which is that you either go from you brute force on the left, which is iterate everything on the left and then do some lookup on the right, or try everything on the right and then pre-process everything on the left so that you look it up, right? What I mean by that is that, for example, if you go negative infinity or whatever, but if you say 1, that means that, okay, let's say to the left we keep for the left we only go to 1, then what is the longest streak that we're going to keep that is 2 or 1 or greater, right? And in this case, this is going to go up to 2 because this is the streak that goes all the way to the end. It doesn't, like you can't really go any better before that, right? So that's really the idea. And the pre-processing on this one is a little bit simpler because you're just counting streaks all the way from the very end, right? There's no like interleaving, there's no subsequence or anything. It's just from the very end. So that means that from the first moment that you start breaking, then that's where you should be. And then the brute force on the left side would just be binary search on that. I think that's my idea. And so let's get started. Yeah. And again, everything that I say, I pretty much figured this out while kind of talking it through. So I didn't have a strong idea like immediately like I sometimes do. But yeah, but then now let's process the right? So maybe the naming things is hard. I'm just trying to figure out how to name things, right? We could actually pre-process the left and because it's just slightly easier to write, or the indexes are a little bit cleaner. Yeah, maybe not. I don't know. Doesn't really matter, I think. But oh yeah, we have to convert array to negative infinity plus array plus infinity. And this is a O of n operation to add these two things. That's the way that I did it. But that's okay because we're only doing it once. So yeah. Okay, so then now we have I mean, I guess there are a couple of ways you can think about writing this. Actually, you know what? I lied. I think I want to go to the end because that way, when I binary search, it'll be more straightforward. Because then, versus like binary search on the upper bounds, on the lower bound. I don't know. Maybe that's just me thinking through it a little bit. So maybe the for loop is a little bit confusing, but yeah. And here we can actually skip n-1. Right? I mean, I just kind of wrote this out to be from the last element, but last element's going to be infinity, so we can actually focus on the sentinel and having this, comparing it to the next element, which is why we have, so if array sub I is less than or equal to I plus 1, then now, maybe I would call this the suffix, right? Suffix, we just call it, maybe maybe negative infinity times n, right? And then here that means that yeah, so as soon as it ends then we break, otherwise this is almost like a streak thing. So then now you have a array sub I or not array, suffix sub I is equal to suffix sub I plus 1 plus 1. Of course, we want to set the last element, n minus 1 is equal to 0. Maybe equals to 1. I don't know. No, I guess it's equal to 1 because you want it to include itself. So then now these are the longest non-decreasing streak from the reverse. So that, yeah. So that means that another way to say it, of course, is that suffix sub I. And actually, what I said about binary search, now that I think about it a little bit more, should not matter, right? Because we could probably do a two-finger thing, but yeah. So let's keep it that way. But yeah, suffix sub I should contain the longest suffix streak, increasing streak, or non-decreasing as they call it, longest monotonically increasing streaks starting from I, which is, you know, there were only one number because it goes all the way to the end, right? But yeah, but then now you have for I in range from 0 to n, and here this one you do want to be 0 because then, you know, but yeah, and then the negative infinity is interesting, right? But yeah, but I think you just go from so now instead of binary search, which was what I actually initially thought of, you could do a two-finger algorithm, right? So now for each I, we want to figure out the best thing to merge, which of course is going to be the smallest, or I guess it is the smallest, right? The smallest array sub I that is connected to the end or something, which is another way of saying that suffix sub I is greater than equal to 0 or something like this, right? Or maybe, yeah, no, that's right. Greater than equal to 1. I guess it can't be really be 0, but yeah, something like that. And here we can keep track of on the right side, right? So then we have a right pointer is equal to 0, right? So while suffix sub right is less than 0 or less than or equal to 0, or array sub I is greater than, strictly greater than, because is equal is okay, then right, then we move to the right, and this will always terminate because suffix sub right of the last element is going to be 1, and suffix sub right is going to be infinity, so that would never be true. So that for the last element, right? So yeah. And then now we can say, but we have to make sure that this is a streak, right? So if, and let's actually start from the first element as well in this case. So then now if array sub I is greater than or equal to array sub I minus 1, so we have a streak from the left side, then this is good. So then we have a streak of length I plus 1, right? And of course, else we break, and we just return something called best. We haven't defined best yet, but best is equal to infinity, and then here we get to, okay, so we have a streak of length I plus 1 on the left side, and then on the right side we have suffix sub right streak. So then now all we should be able to need to do is suffix sub right, so I plus 1 plus suffix sub right is going to be the new length of what we keep, right? So keep is equal to this. So then now the removal is going to be n minus keep. So we just do, and we should be good, hopefully. I mean, I don't know. Oh, -1. I mean, -1 should not be possible. Oh, yeah, okay, yeah. I guess in this case, this goes all the way through. How do I have -1 exactly? I mean, it's still not a. I mean, I understand why this would be a tricky case because I think this just goes all the way through. No, but I don't think this goes all the way through because otherwise, if it does, then this would be infinity. But so I is going to be I plus 1. So keep. I mean, the keep is a little bit wrong then. We're keeping more elements than we should. Did I mess up the thing? Maybe I did. Maybe there's an off by 1 on the keep. I plus 1. Oh, I see. Yeah, I get what. So the case that I'm missing is that I is exactly equal to right. If I is equal to right, then suffix of right would include I, and I plus 1 includes right. So here we want to say right is at least I plus 1, right? Because there has to be at least the next element to connect them. Okay. So yeah, so it's going to be max of right and I plus 1. Okay. Oh, but now in this case, because we go all the way to n, we don't need to go all the way to n because we can go all the way to n minus 1 and that's fine. Because the n is infinity and then it just checks that this is n plus 1, which is our bounds and then stuff like that. Oops. Very sloppy, but okay. Let's give it a YOLO submit. 2 wrong answers last time, and today we have at least 1 wrong answer. Apparently, I did this 4 years ago, a long time ago. But let's see. Let's take a look real quick. The output is 10, but we expected 8. So my answer is worse than the answer, which means that it could be an algorithmic problem. Okay, so you have this one. We have 11 elements. So 11 elements, removing 10 is probably a little bit high. Okay. Maybe I misunderstood some of this. Oh, the idea is removing this. Okay. Oh, I see. I did miss a case for this one then. I guess so. I mean, the case is that, okay, so the reason why we did this change is because we assumed that there will always be 0 element. But I think one thing that we have to add is that, for example, if I have this case, well, let me be a little bit more articulate. This is pretty sloppy. I feel a little bit bad. But basically for this one, this is the answer, and that means that there's no contribution from the left side, because we're thinking about things on the left plus right, like left, we delete the middle, we have the left side, the right side. And then I try to get rid of it by sentinels, but apparently, oh yeah, we got rid of it because I changed this to 1 instead of 0 to make this easier, but then as a result, I got rid of that sentinel as the beginning value for counting right. So that part is a little bit sloppy because in a weird way, I needed a double sentinel. I think that's what I needed, but that is kind of hard to. It's very weird that you need to, so I don't think about it. I mean, of course, you can also just do other cases. And yeah, the thing with this one, the hack that I did for this was for the opposite case where kind of anyway, if you have like 1, 2, 3, I don't know, -5. I know there's no negative number, but you get the idea. Is that if you have the prefix, then this just doesn't go through. But I think so anyway. We should put that in there. So like let's put 10, 20, 30, and 5 or something. And we didn't fix it yet, so I know, but I just want to curious. Okay, so at least that's right. But in any case, yeah, so we have to fix this case, and we fix this case by considering the case where nothing's contributing from the left. This is basically all figuring out the contribution from the left, so we just have to add this, which is to say, yeah, so maybe the base case could be a max of suffix. So the max of suffix is going to be longest streak, so like n minus this is going to be good enough, I think. But still very sloppy, I think. Well, it's not even right, so even more sloppy. Oh, it has to be this n plus 1 because we have to take out the sentinel value, which is the negative infinity, which we kind of counted because of the way we did it. Okay. But then now we get a -1 for 1, 2, 3. Why? Tell me. Is this thing max of suffix? It's gonna be 1, 2, 3. So we get all. Oh, this is kind of awkward actually, because then now, because we have the entire array, we actually count the first element. So then this +1 double counts. So in theory, you want something like this, but it's just so ugly now. My beautiful, beautiful code. But you know what they say? Beautiful code, if it's incorrect, it doesn't matter. But yeah, it's not beautiful if it's wrong. But yeah. Yeah, I mean, I feel like now I probably could handle some of these a little bit better. I don't know how I feel about this anymore. Maybe I could have just, maybe this is worse, but maybe I could have just written something like this, right? If I is equal to 0 or whatever, right? So like this is probably fine, maybe, maybe not. Right, -1. Oh, because we still count. Okay. Well, what I mean is that now this should not need this anymore. It's okay. I think that's a little bit, yeah. So that's a little bit cleaner, I think. At least or in the sense that this really tells you why we're doing this kind of thing, right? Yeah, and I think this is more reasonably what I want. So yeah, what's the complexity here, right? Well, like I said, this is going to be O of n, but I mean, you know, we expect that because this is going to be O of n and this is O of n. So we're going to have O of n time, O of n space due to this thing, but this also takes O of n space. And yeah, so linear time, linear space, and that's all we have for this one. Let me know what you think. Thanks for watching. I mean, I don't think this should have been so bad, but I don't know. I just made a lot of silly mistakes. But I mean, I guess I made a lot of silly mistakes last time too. How did I do it last time? Did I do a binary search? No, I did it with prefix and suffix and 2 pointers. I guess I did it the same way, but I just ran into issues. I think this is also clean as well, the idea of it anyway. I mean, I got 2 wrong answers, so how clean can it be the first time I get it wrong? But yeah, how did I return 9? That is actually wild. I don't know. But yeah, that is all I have for this one though. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.